All right, let's just jump right in. I want you to imagine something. A moment, way, way back in the deep history of life, when the universe kind of woke up and became aware of itself. And I'm not talking about in a brain or even in a neuron. Nope, something much simpler. A single cell, just floating around in some ancient ocean, sensing light for the very first time. In that tiny little chemical flicker, something incredible happened. The universe didn't just react anymore. It started to experience.
You know, we can trace the chemistry of those first cells. That part's doable. But there's a much tougher question, isn't there? When did the lights actually turn on? When did simple information processing, just reacting to the world, turned into subjective experience? When did feeling actually begin? Somewhere between a bacterium just responding to a bit of sugar and you, right now, listening to this, that's where consciousness popped into existence.
So let's actually trace that incredible path. We're going to follow the thread from that very first cell that could sense its environment all the way to the first organism that could remember, and then, finally, to the first mind that could actually ask, what is it like to be me? It's a journey that spans billions of years, taking us from basic chemistry to the mind-boggling mystery that's sitting inside your head right now.
Okay, so our story really begins at the absolute starting line of life. Back then, survival depended on just one simple question. What's out there? And this wasn't about thinking or anything fancy like that. No, it was all about chemistry and the fundamental need to tell the difference between something good and something bad.
I mean, think about it. The first cells were basically just little bags of self-replicating chemistry. To make it, they had to find food and, avoid poison. So, they evolved these proteins that acted like tiny locks for specific chemical keys out in the world. And when the right molecule, the key, plugged into that rock, it kicked off a response inside the cell. That sensation at its most basic level, right? An outside signal triggers an inside response, and that response helps the cell stay alive.
Okay, for a really cool example, just look at an E. coli bacterium. It's got these receptors that grab onto sugar molecules. But here's the amazing part. It doesn't just react blindly. The cell is constantly comparing how much sugar there is now to how much there was just a few seconds ago. If the sugar level's going up, its little motor makes it swim straight ahead. More of this, please. But if the sugar level drops, it starts to tumble around randomly to find a better direction. I mean, that's sensing, memory, and decision-making all happening without a single neuron. It's incredible.
And this is the absolute key point right here. The way those proteins are arranged inside the cell is about the sugar outside the cell. The world out there is being represented in a very simple way inside. And that representation, that connection between an internal state and an external reality, well, that's the bedrock. That's the first tiny seed from which all experience, all consciousness would eventually grow.
So you can see how basic sensing was a total game changer. But to build a richer, more complex experience, life needed a serious hardware upgrade. And that upgrade came in the form of cells that were specialized for just one thing: processing information.
So, fast forward to about 700 million years ago. This is when the very first neurons show up and the ancestors of today's jellyfish. At first, they were just simple electrical wires, really, connecting sensory cells to muscle cells. But that one little step in between, it changed everything. Because neurons can connect to other neurons, and that's how you get networks. And inside those networks, something brand new becomes possible, integrating all that information together.
Now, before we got to true vision, we had things like the eye spots on a single-celled critter called euglena. These are not eyes in the way you and I think of them. Not at all. They can't form an image. But what they can do is tell the organism where the light is brightest, which is super useful for swimming towards your food source. So it's not just sensing light or no light, it's sensing the direction of the light. That's a simple little spatial map of the world, right there.
But the real revolution, that came with the first image-forming eyes, like the ones on those ancient trilobites. All of a sudden, an organism could see edges and shapes and movement. The world went from being this, vague soup of chemicals and light to a landscape filled with actual, distinct objects. And making that happen required a huge amount of neural integration, taking all the signals from thousands of little light detectors and stitching them together into one coherent picture. Okay, but think about this. A camera can see a picture, right? But it doesn't experience it. So what's the missing piece of the puzzle? Well, it's memory. And memory isn't some kind of magic. It's physical. It's built on this really elegant principle. When two neurons fire at the same time, the connection between them gets stronger. You've probably heard the phrase, neurons that fire together, wire together. That's it. That's the physical basis of learning, right there.
So why is memory such a big deal for consciousness? Well, because memory creates continuity. It's what lets an organism compare this moment to the last one. Without memory, every single sensation is just an isolated blip. It just happens, and then it's gone. But with memory, those blips get linked together into a flow, a sequence, a story. And this linking of time, this feeling of being a continuous self moving through a stream of events, that might just be the secret sauce that turns simple sensation into what we call experience.
Okay, this brings us to a really fascinating next step. Even if an early animal was having experiences, those experiences were probably, well, anonymous. There was seeing, but no one doing the seeing. There was feeling, but no self to feel it. For consciousness the way we know it, experience had to become my experience.
And this idea of a self probably didn't just pop into being all at once. It's more likely that it emerged in layers, kind of like an onion. At the most basic level, you've got the bodily self, just that simple sense of where your body stops and the rest of the world starts. Then you get the narrative self, that feeling that you're a continuous person with a past and a future. And then, at the very core, you have the reflective self, which is the wild ability to think about your own thoughts.
That narrative self is where things get really, really interesting. Check out scrub jays, for instance. They don't just remember where they hid their food. They remember specific details about the whole event, like when they hid it, and even who might have been watching them do it. That's what scientists call episodic memory. It's basically mental time travel, the ability to go back in your mind and relive a past event from your own point of view.
And that brings us to the deepest layer, metacognition. Basically, knowing what you know. But how on earth do you test for that in an animal? Well, scientists came up with a really clever test. You give an animal, say a rat or a monkey, a really difficult task. But you also give them an opt-out button, which gives them a smaller but guaranteed reward. And what happens? It turns out they almost always hit the opt-out button on the trials they're most likely to get wrong. In other words, they know when they don't know. Okay, so let's recap. We've traced this incredible path from simple sensing to memory to a pretty complex sense of self. We've put all the functional pieces on the table. But even after explaining all of that, we're still left staring at the ultimate mystery. And this brings us right to the core challenge, which the philosopher David Chalmers famously split into two different problems. First, there's the so-called easy problem. And trust me, it's anything but easy. It's explaining all the brain's mechanics, right? How it processes information. It's insanely complex, but it's a scientific problem we can slowly chip away at. But then there's the hard problem. And this one is a whole different beast. It's explaining why. Why should all that physical processing come with an inner, subjective experience? Why does it feel like something to see the color red or to taste a cup of coffee?
And the honest answer is, right now, nobody really knows. There is zero scientific consensus. You've got a few big ideas out there. Some folks think consciousness just emerges. Once a system gets complex enough, poof, the lights turn on. Others argue that this whole subjective feeling is just a kind of powerful illusion that our brain creates. And then you have a really wild idea called panpsychism, which suggests consciousness is a basic property of the universe, like mass or charge, and our brains are just really good at tuning into it.
And what was once a purely philosophical problem is now staring us right in the face. As we build more and more powerful AI, we have to ask, what, if anything, are they missing? Some theories, like integrated information theory, suggest that today's AI isn't conscious because its information isn't deeply integrated in the right way. But could we build one that is? And even if we did, here's the kicker. How would we ever know for sure? We can't get inside another being's head to see if the lights are on, whether that being is made of brain cells or silicon chips.
So after this entire journey, we're left with this one kind of profound final thought. Maybe we've been looking at this all wrong. Maybe consciousness isn't something that just happens in the universe. Maybe consciousness is something the universe does. I mean, think about it. We are literally built from the ashes of stars. And the awareness that we use to look back up at those stars, that's made of the exact same stuff. We aren't separate observers looking in on the cosmos. We are the cosmos, in a temporary arrangement that's just complex enough to wake up and wonder what it all means.